So in today's lesson, we are looking at naming and drawing esters and how they are used in reactions and how we can produce them. You should also be able to write some information about their physical and chemical properties at the end as well. So esters are actually responsible for many of the odors we actually can smell. So anything like fruits and flowers, synthetic esters like found in perfumes and added to foods, those are all basically made in the lab for us to smell. Esters contain something called the ester bond. So very similar to our carboxylic acid, except it doesn't have the hydrogen. So it's carbon double bonded to the oxygen and another oxygen and the rest of our carbon molecule on either side. Esters are formed through something called a condensation reaction. And this is going to occur between a carboxylic acid and an alcohol as our starting material. So this process can also be called esterification. Condensation means that we should have water coming off our molecule. So let's start off with naming and preparing esters. It's just easier to name them by looking at the starting materials that are required to make them. So remember that you need carboxylic acids and alcohols. So basically, if you have an acid and an alcohol, they can react and produce a salt, which is basically our ester here. The name of our ester has two parts. The first part is you're going to name the alkyl group that's on specifically the alcohol here. So your alkyl group has or comes from the alcohol. The second part of our name, so basically the parent name, you can consider if you want, the parent name is going to come from our carboxylic acid. What we're going to do is we're going to change the ending of that name, instead of being a carboxylic acid, into O8. So O-A-T-E there at the ending. So let's look at a specific example here between the reaction of ethanol and butanoic acid. So here is ethanol. Here is our butanoic acid. So we're going to do the reaction and naming at the same time. So what's going to happen is your hydrogen from the alcohol group is going to come off. Your hydroxyl from the the carboxylic acid group is going to come off, and the rest of that alcohol gets attached to that specific carbon. So the oxygen gets attached to the carbon, so you can see that part right here in the end. So it's still 2 carbons along here, 2 carbons along here. The hydrogen and the hydroxide come together to make our water. So now, in terms of our name, the first part of our name comes from the alcohol, and we're taking it as the alkyl group. So meaning you're kind of like naming it as the branch. So here we have a 2 carbon long branch, so it's ethyl. And then you name the carboxylic acid part. So you use the butanoic acid, take off the oic acid, add O8. So it's ethyl butanoate, just like that. So this is the alcohol group. Ethyl is our alkyl group, and butanoic acid is our parent, but we're ending it with O8 now to indicate that we have an ester. So again, let's look at reactions and naming together. So here we have the reaction between butanoic acid, which I'm going to assume you know how to draw, and methanol. So it's a methyl group with an alcohol group on it. And it's going to give us methyl butanoate. So how does that happen? Your hydrogen, hydroxyl group comes off, the carboxylic acid, the hydrogen group comes off to make water, and the rest of this molecule gets added to the carbon that's double bonded to that oxygen there. Okay, so we still have that double bonded oxygen and I'm going to just draw the rest of it. I'm just taking the CH3 off. So 1, 2, 3, 4. And this one methyl group attached to the oxygen gets added on this side. So that's our methyl group there. So oxygen, methyl group. Hydrogen comes off, hydroxyl comes off, and that's going to make our water. So that is a methyl. You name the alcohol group first. And then butanoate. So the butanoic acid becomes butanoate. Here we want to draw the structural diagram and write the IUPAC name for the ester formed in the reaction between propanol and benzoic acid. So I'm going to assume that you know what those look like. So propanol, 3 carbons long, alcohol, plus your benzoic acid. So benzoic acid means that I have a carbon and the OH. One key thing to keep in mind that I forgot to mention is you always are going to have these catalysts. So you're going to need heat and you're going to need concentrated sulfuric acid in order for this reaction to occur. Otherwise it occurs very slowly. So this is going to speed up our reaction. So I'm going to add that here. So I have heat and sulfuric acid. So again, what's going to happen is your hydroxyl group is going to come off, the hydrogen comes off, and the rest of our molecule, this oxygen, is going to add to that carbon on the other side there. So our molecule is going to look like this. Carbon double bonded to the oxygen, and now we have the oxygen with 1, 2, 3 carbons. So 1, 2, 3, and you also have the water that came off. So in terms of our name, we take the alcohol group and we add the YL, so it's propyl, and you take the benzoic acid, drop the oic acid, and add O8. So that is called propyl benzoate. Here we want to write the condensed structural diagram equation for the esterification reaction. So basically we want to produce an ester, but we want to specifically produce this ester. So sometimes remember that carboxylic acids could be written as COOH because they're found right at the very end. Well, our ester, because they're found in the middle, they can have that COO look to it. So it means the same thing. So COO, where should I write this? COOR is usually what it'll be written as. The first oxygen is the oxygen that's double bonded there, and then the second one is the alcohol group, or the rest of that molecule there. So that's what the two forms will be. So if you notice that it's right in the middle, COO, that means it has to be an ester. So we want to write the names of the reactants and then finally name this product. So maybe if it helps you to draw it out with the carbon double bonded oxygen, try and draw it that way. So here we have CH3, CH2, C double bonded to that oxygen, and then you have the O and the CH2, CH3. So those are the same things. So remember that the double bonded carbon, this side of the molecule, so basically where our bond formed is right here. So this part of our molecule, remember, comes from the carboxylic acid. So let me try and get an example back here. So here's an example. So the carbon that's double bonded to the oxygen, this part right here would have came from our carboxylic acid. the part that's attached to the oxygen technically comes from the alcohol. So if you can look at your diagram and identify which comes from which one of our starting materials, you should be able to name everything that they want us to do here. So like I mentioned, this part would have been our carboxylic acid part. And this side technically would have been the alcohol that we would have started with. So can you tell me how many carbons were in our initial carboxylic acid? Absolutely. You're looking at the number of carbons on this side. So I have 3. So this side, it should have been propanoic acid. So that was our original starting material, propanoic acid. And can you tell me how many carbons were originally in our alcohol? Again, yes. So if this is my alcohol portion, I would have seen that it had 2 carbons. So I'm really just adding the hydrogen here. So I would have been having this as my starting material for the alcohol. So this is ethanol. So those two together are going to produce this carboxylic acid for me. So remember, I'm going to need heat. I'm going to need H2SO4, sulfuric acid. And what's going to happen is your carboxylic acid, hydroxyl gets removed, this guy gets removed, and this gets added to the carbon there. So I'm just going to do a stick drawing here, but really, actually, I'm going to see if I can squeeze it in. So we get CH3, CH2, and we also get water. So if we want to name this final product, remember that you name the alcohol group first. So it's called ethyl. So that's this group right here. And then you name the carboxylic acid group, drop the oic acid and add O8. So this is propanoate. So this organic product is called ethyl propanoate.